Now, the thing is, if you go to, say, the paper and you look up what the pressure readings are using a barometer, okay, just like thermometer is for temperatures, barometer is for pressure, for air pressure. And generally speaking, you will find that it'll be done in millimeters of mercury, just like mercury is used for thermometers. Okay, it's a little bit bigger number for barometers, but they measure air pressure. But if you look in the paper, it doesn't use millimeters at all. It tends to say things in inches for this area. And then, as we just heard on the video we watched, for yesterday's storm, they were talking about another unit altogether, millibars. Well, our book, and pretty much all chemistry books, have all of these terms in them for pressure. In fact, the one the book seems to like the best is kPa, which is kilopascals. STP, standard temperature and pressure, well, the pressure is 1 atmosphere. The ATM stands for 1 atmosphere. And then, as I said, generally speaking, you'll find millimeters of mercury, or you can even find it in pounds per square inch. And in fact, really, this is the one that kind of gives you a feel for what pressure is anyway. It is the amount of force, or weight, if you will, that's applied to a certain area. And that's basically what your pressure is. You may not realize it, but we feel pressure, all of the air above our head, all the way up into space. All of that air has a certain amount of weight to it, and it's pressing down on our heads. It's not very much. Okay, it's basically 1 atmosphere being just 14.7 pounds, but it's stretched out over thousands and thousands of feet. And so we don't really feel it, except maybe sometimes when it's a really muggy day or something. However, if you go to, say, somewhere like Denver, the Mile High City, it's a little bit thinner air there. There's much higher up elevation. Balls actually travel better in that elevation because there's not as much air pressure pushing down on them as it does here. Now, the idea of this paper is just to do a little bit of practicing of going back and forth between units that you might encounter in your everyday life and the units that we've got in the book. But there are all these different kinds of units for pressure. And so we want to change things and do just kind of like we did in the last unit, where we had all those mole conversions. Well, now we're going to do pressure conversions. And hopefully you'll see that we're doing them about the same way. So, first off, we've got 1 inch equals 2.54 centimeters. Now, we want to get to millimeters. Well, it turns out 1 centimeter is 10 millimeters. And so, we really could say that 1 inch equals 25.4 millimeters. And so we just move the decimal over 1. So if we want to get what the paper would say, rainy day, 29 something inches for the barometer reading, we're just going to change it like this, 29.79 inches times, draw my line, just like we were doing a mole problem. Now we want to get rid of the inches, so we're going to put the 1 inch down here, and up here we're going to put our 25.4 millimeters. And so really this is just a simple multiplication problem. And so 29.79 times 25.4, and it turns out that this is basically 756.7 millimeters. So that you can see that it's just a little bit less than the 760 would be for normal 1 atmosphere. If we want to change the other one, then we would take 30.48 inches, and again times 25.4 millimeters per inch. and this one comes out 774.2 millimeters. So basically, going from a sunny to a rainy day, we have a drop in about 18 millimeters. They're talking in the video about having something that was dropping 24 millibars. Well, what do we do with millibars? Well, it turns out down here, this is the time I most often notice them using millibars. This was for Hurricane Katrina. It went from 1,008 millibars down to 902. So it dropped 100 millibars when, as the hurricane was forming. Notice that when it's a tropical depression, it's just 35 miles per hour. Major hurricane, 175 mile per hour winds. So big drop in pressure causes a lot of wind. So here's the key. 1 millibar is basically 100 pascals. Up here where we have the kPa, that is K, kilo, 1,000 pascals. So we can start to get close to the same thing. So basically, if I start with 902 millibars and then 100 Pa, that's the pascals, per 1 millibar. Notice how every time I do one of these, whatever's here has to be down here, so that part gets canceled. And this will be 902 and then 2 zeros pascals. Now, we want it to be like it was at the top of the page, kilopascals. Well, kilo, just like kilometer and kilogram, kilo means 1,000. So 1 kPa has 1,000 PAs. So basically we're just dividing by 1,000 and we end up with 90.2 kPa. So that gives you a feel for, again, 1 atmosphere, standard temperature and pressure is 101. Major hurricane, it's dropped down to 90. So that kind of gives you a feel for how much pressure change occurs with really violent weather. So what I've done here is just transferred or transformed it into one particular unit. On the paper, we want to go to all the other units as well. So now, you don't really have a lot of room up here. You do have down here, but you can, of course, do this on a separate piece of paper as well. But let's go back to the first example where we started in inches. Now we have it in millimeters. Well, what if we want to go to kPa? Well, the way we would do that is, let's start off with the lower one. We write down what we want to change. We want to go to the kPa, so we're going to use the 101.325 kPa. What do we want to get rid of? The millimeters of mercury. So note, both of these numbers were at the top of the page. They're equivalent to each other. They're different numbers because they have different units. So when we want to change from one unit of pressure to another, we have to make sure whatever's here is going to get canceled out down there, and it's basically multiply and divide. And so when we do this, 756.7 times the 101.325 divided by the 760, we find that this is 100 point, let's say 9, a little bit of rounding, and then we're going to have now kPa, because that's the only units that are left. Okay, now I want to go to, say, the pounds per square inch. So I could do the same thing I just did, except this time I'm going to have the 14.7 on top and the 760 on the bottom. So see how similar those two, but instead of ending up in kPa, I'm going to end up in the pounds per square inch. And so in this case, 756.7 times the 14.7 divided by the 760, and let's make sure I do that right. I ended up with 14.64 if you want an extra digit, and then this one's pounds per square inch. Now, just to kind of show you, well, what if I had this one, 14.64 pounds per square inch, and I wanted to go back to kPa. Well, then I would put the 101.325 kPa on top. Down on the bottom, I put the 14.7 pounds per square inch. Because again, that part will get canceled out. And so when I do this, 101.325 divided by the 14.7, and lo and behold, I'm back to my 100.9 kPa. The point being, I don't actually have to go back to the original number every time. I can start with whichever one I got to, and then just use the right combination in my ratio to get to any other units I want to. The key is, here are all my ratios. In other words, one of these numbers will be on top, and one of these numbers will be on the bottom. How do I know which? Whatever I want to get rid of is the one that has to go on the bottom, so that that part will cancel out. So part of your homework will be to finish this so that up here for number 1, now that I have them in millimeters of mercury, I need to switch them into atmospheres, kPa, and pounds per square inch. And for the second one, well, I got started with the 902. Here it's in kPa. Here it's in pounds per square inch. Have to do the atmospheres, and also want to change the 1008 millibars so that it's in the different units. Because you will have problems as we go through the unit in which sometimes it'll be in kPa, and sometimes it'll be in atmospheres, and sometimes it'll be in millimeters of mercury. And to finish the problem, you may need to change one of them so they match, so that you will be able to cancel things when they're done. So any questions on this part?